evaluating statistical claims. So from this PDF, you have asked me to do question number 3 first of all. Let's start with this one. A psychologist designed and conducted a survey. By the way, if you have statements this long, what you should first do is look at the last sentence to see कि वो पूछ क्या रहे हैं. Okay. So what's the largest group to which the results of the study can be generalized? Look at the last sentence, look at the question that they're asking, and also look at the options that are given, and then read the question statement so that when you're reading the question statement, you know exactly what to look for. Okay? So they're saying what's the largest group of students? What's the largest group to which the results of the study can be generalized? 35 students in the sample, all students at school, all middle school students in the city, all students in the city. Okay, so now keep that in mind when you read the question statement. Okay, so they're determining whether playing a certain educational game increases the middle school students' accuracy in adding fractions. Okay. The random sample of students is chosen from all the students at one of the middle schools in a large city. So 35 students are chosen from one school. And then they have some results from that study. They found that the students who played the game showed significant improvement in accuracy when adding fractions. Now, for students in that particular school, this is the result that we have. The sample has been taken only from one particular school. Can we generalize that to all students in the city? Is that possible? What are the options that are given? It says 35 students in the sample. Can we apply this to just 35 students in the sample? स्कूल के बाकी लोगों पे अप्लाई कर सकता है. All students at the school, okay. All middle school students in the city. All students in the city. Which one of these is it going to be? C or D? A दोनों में से कोई हो सकता है, इसके अलावा तो नहीं हो सकता, right? All students in the city, no. 35 students in the sample, that's also not possible. But now, look at the other two options. What is the sample size? 35, and all of those 35 students are taken from one of the middle schools in a large city. Can the results be generalized to all middle school students in the city? You're only taking a sample from one school. How can you generalize that to all schools in the city? That would only be possible if you had taken a sample from multiple schools, right? If there were 100 schools in the city, if you had taken a sample from let's say like at least 10, 15 of them, then you could generalize that. But you've only taken that from one particular school. You can't generalize that to all schools. The school that we're talking about, it's a middle school. So all the schools, or all the students in the school are middle school students. उनमें उसके अलावा कोई है ही नहीं और. So we can say that this applies to all students at the school because all students at the school are middle school students. उसके अलावा तो कोई है ही नहीं students. It's a middle school. Is that okay? So it's going to be B, not C. You cannot take a sample from one school and generalize that to all schools in the city. That would not work. Then it would only apply to A-level students at the school. No, unless you're taking sample from multiple schools. आप 55 से सिर्फ ले रहे हैं A-level students का. अगर आप A-level students का ही sample लेते हैं from 10 schools, let's say, then you could generalize that to more schools as well. But if you're taking sample from just one school, you cannot generalize that. Okay. All right. Now, the next one is 5. Evaluating statistical claims. Okay, question number 5. To determine the mean number of children per household in a community, this person surveyed 20 families at a playground. So you're surveying 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following statements must be true? Must be true. Keep that in mind. It says, which of the following must be true? The mean number of children per household in the community is 2.4. No, because it does not necessarily have to be exactly 2.4, right? A determination about the mean number of children per household in the community should not be made because the sample size is too small. Okay, let's keep this in mind. Let's look at the other options as well. The sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. Okay. The sampling method is not flawed and is likely to produce an unbiased estimate of the mean number of children per household in the community. Acha. Now let's evaluate each of these options one by one. The first is definitely true because एक sample का mean 2.4 आ रहा है. We can't generalize that to the whole population. Now the second statement says the sample size is too small. Can we say it's too small? How do we know if it's too small or too large? We do not know what the total number of households in the community is. What if the total number of households in the community was 25? 25 means if you're taking a sample of 20, that's a big enough sample. But if the total number of households was 1,000 or maybe 10,000, then it might be a small sample. So we can't necessarily say that the sample is too small. So we can't say this for sure. Okay. The sampling method is flawed and may produce a biased estimate of the mean number of children. What do you think about this? Can you think of a reason why it could be flawed? No? Playground mein hai, if you're taking a sample from a playground, most likely the families there are the ones who have children, right? There might be other families who don't have any children at all. They would not be at the playground. So if you're just calculating the mean for those families who do have children, right? So that's going to be biased because there will be some families who don't have children and they're not at the playground unless they want to pay themselves, which most likely would not be the case. So वो नहीं है. So it's a biased estimate. Okay, so that's C. Is that okay? तो उसमें थोड़ा सोचना पड़ेगा. All right. Okay. Let's move on. So this was the statistical claims PDF. The next one is sample statistics. Okay. Sample statistics. All right. So you've asked about question number 2 and 3 from this PDF. Okay. Question 2. Researcher interviewed 411 randomly selected US students and asked about their views on the use of nuclear energy. Okay, you have this data here. Strongly favor, somewhat favor, and so on. Okay, the total number is 411. The table summarizes the responses. The population was 300 million when the survey was given. Based on this sample, what's the best estimate of the difference between the number of residents who somewhat favor or strongly favor the use of nuclear energy and the number of those who somewhat oppose or strongly oppose it? Okay. Difference between these two sets of people, one set of people is who either strongly favor or somewhat favor, and the other set of people is who somewhat oppose or strongly oppose. What's the difference between them? First of all, let's calculate these totals. 56 plus 214, what's that? 270. 104 plus 37, that's 141. Okay. What's the difference between these two numbers? 270 minus 141? 129. So out of 411 people, the difference between these two set of people is 129. What would be the difference if the total number was 300 million? How do you find that? Just calculate the ratio. 129 over 411 multiplied by 300 and see what that is going to give you. 129, 129 divided by 411 multiplied by 300, and that is giving me 94.16 million. Remember, this number is in millions. And now they want you to round off your answer to the nearest whole number. What's the best estimate in millions? Okay. What's the nearest whole number in millions? 94. So you say 94 is your final answer here. Is that okay? Any problems? No? Okay. The next one is question number 3 from this PDF. The results of two random samples of votes for a proposition are shown above. Percent in favor for 52% for sample A, and percent in favor for sample B is 48%, and we have their margins of error. So there are two random samples, and they're given some proposition. In sample A, 52% are in favor. In sample B, 48% are in favor. Okay, they're collected from the same population. Which of the following is the most appropriate reason that the margin of error for sample A is greater than the margin of error for sample B? Remember, how is what factors affect the margin of error? Remember that? Sample size. If the sample size is big, the margin of error is going to be lower. That's one reason it could be different. And the other reason is the actual data itself has more variation, but we're collecting sample from the same population. So that's unlikely to be the case that the actual data is that varied. Now let's look at this. Sample A had a smaller number of votes that could not be recorded. Sample A had a higher percent of favorable responses. Sample A had a larger sample size. Sample A had a smaller sample size. So one of these is going to be true. Let's look at this again. Margin of error for A is greater. If the margin of error for A is greater, its sample size should be smaller. So that means A had a smaller sample size. That's B.